Okay, here's our first super simple STEM project using a single sheet of paper. And the paper can be a regular standard size copy paper or printer paper. And you use only a few tools here, pencil and a ruler in addition to your paper. Our goal of this project will be to construct a flying wing, and the flying wing will be modified during flight in order to accomplish a particular goal. Our goal for this project will be to fly our paper glider a distance of 10 meters to land on a target. Accomplishing that task will require some modification or engineering along the way. So remember what the letters in STEM stand for. The S for science involves repeatability using the scientific method. So you're going to be, after constructing your paper flying wing, you're going to be doing it over and over again to learn from mistakes and improve upon it. The T for technology involves the use of tools. The paper itself is a tool. The pencil is a tool, and the ruler is a tool. The E for engineering. You're going to be tweaking or modifying or engineering the design of your flying wing in order to improve its performance to accomplish the goal of flying a distance of 10 meters. And finally, the M for math will utilize the ruler to make some measurements here, as well as to put together the geometry of our device. So we incorporate all the letters of a STEM project. Now I know sometimes STEM is referred to as STEAM. They add an A in there, and the A is for art. If you've got time, you can certainly add some artistic flair to your flying wing and make it a little bit more exciting as well. So now to our instructions on how to make our flying wing. Here we go. Starting off with our piece of paper, you can have students measure the length of the paper, which standard size is 28 centimeters long, and have them divide the paper in half. Some people refer to it as folding the paper like a hamburger bun. We're going to encourage the use of measurement, so you can have them measure from one end 14 centimeters, both on one side and the other side, making little tick marks and then connecting those tick marks with a line. That line, when drawn, enables them to visualize the midway point in the paper and then simply fold along that line. So folding along that midway line will give you a standard sheet of paper folded in half. Once you have folded it in half, open it up again, so we have the fold down along the middle of the paper. Next step, using your ruler, measure 2 centimeters from one end of the paper, and likewise do the same thing on the other end of the paper. You're going to connect those 2 tick marks with a line, and then you're going to fold along the line. Now, if you don't have a ruler available to you or pencils and you just want to do this as a quicker project, you can use the thickness of your finger in order to accomplish the same goal. Once you've made that first fold, you're then going to fold again, nice and tight along that first fold, making sure that each fold is parallel to the first one. Parallel, that's a term used in math. You're going to continue doing that for a total of 5 folds. So this is 3, this would be 4, and this would be 5. Once we have these 5 folds made, encourage them to fold the paper in half along that original fold once again, and tighten up the creases. Really fold down hard along those creases of your 5 folds. Now we're almost finished. You're going to take your ruler again and measure in 2 centimeters from each edge of your flying wing, along the top and the bottom of the wing, on both sides measuring 2 centimeters. Now as you do this, you're going to then use your ruler as a straight edge, and you're going to draw lines from one tick mark to the other on both of your edges of your flying wing. Final step will be to fold along those lines that you have now drawn. Folding these last 2 lines are creating what are called the stabilizers of your flying wing. At this point, your flying wing is finished. Let me just demonstrate quickly how to correctly fly your flying wing. This is not a paper airplane, so you don't throw a flying wing. Rather, you glide it. And the proper way of gliding a flying wing is to put your pointer finger on the top of the original fold and your middle finger and thumb on the bottom of the original fold. You'll hold it in your hand like this, and you will gently move and then release. The flying wing's fold is in the front of the wing. You've altered the center of gravity of your paper in such a way that gravity will pull the front of your flying wing forward, increasing the velocity, and because of the fold of the wing, Bernoulli's principle is coming into play here because the top of your flying wing is now curved. The greater curvature is going to provide lift to your flying wing, which is going to allow your flying wing to float and fly through the air. Now, I mentioned the E for engineering. Some of the ways that you can tweak, modify, or engineer your flying wing include the following. You want to present several variables that can be altered along the way. Number 1, the original fold width itself. You can modify that. You can alter that. You can engineer it by changing the thickness of that original fold. Make it 1 centimeter, make it 3 centimeters, make it somewhere in between. Alter the dimensions of that original fold. You can also alter how far in you fold. In other words, changing the surface area of your final wing itself. The greater the surface area is going to have an impact as the same as changing the surface area to a smaller surface area. Change it, modify it, see how it affects the flight. This can be a multi-day project. Changing the shape of the fold itself by folding the folds on the edge of a table. Like this, changes the profile of the wing, increasing the curve, increases the Bernoulli principle, causing greater lift. Now, once your flying wing is flying fairly well, the final modification or the engineering that you can employ is with the stabilizers yourselves. You are flying the wing. Don't let the wing fly you. You fly the wing. So if your wing is flying consistently to the left, folding the stabilizers on the back to the right will cause your wing to fly to the right. If it's flying too far to the right, then fold your stabilizers in the opposite direction. Remember, you're the pilot, not the paper. Once you have engineered your flying wing exactly how you want it, you can enter it into a class-wide competition or just have fun at home by flying your flying wing. And this simple STEM project can provide hours of enjoyment as well as some really good STEM-based lessons when you are modifying and engineering your plane. So have fun with this first super simple STEM project with a single sheet of paper.